Hello everybody, this is our last lecture of the week and it should be short. You can see 15 slides here, so pretty quick. Play from current slide, here we go, let's get started. Okay, so I talked a lot about geohazards from earthquakes and I talked about geohazards from volcanic activity, but there are also geohazards that happen separate from these earthquakes or volcanoes. Right, so earthquakes and volcanoes are usually associated with some type of tectonic activity, right? Whether that be faults, so different types of plate boundaries producing different earthquakes, which will produce different geohazards, or you have volcanic eruptions, either from convergent, divergent boundaries, which can create different geohazards depending on the magma and the boundary, or from hotspots. Right, so all of this different type of tectonic activity will produce geohazards. However, there's a bunch of geohazards that can occur separate from this tectonic activity. Okay, so we're going to run through, and these types of geohazards are, believe it or not, actually some of my favorite to talk about. So I hope I don't talk too long on this, but we'll see. So here we go. Okay, so you can have landslides, rockfalls, and avalanches happening without earthquakes. Okay, so this happens when you have slope failure. Okay, so when you have steep slopes, when you have unstable substrate, so substrate again is the type of material that we're on, so bedrock versus loose soil versus clay, etc. Okay, so that's substrate. When substrate is unstable, it can fail and produce a rockfall or avalanche. Okay, you can also have freeze and thaw. So if you remember when we talked about our different types of weathering, we had freeze thaw happening on the rocks, breaking them down, right? So water gets in the rock, freezes, and then the rock breaks. Okay, so this can happen on a much larger scale and other than individual rock boulders, right? This can happen on rock faces, slopes, etc. This freeze-thaw activity can happen on very, very large scales, producing these landslides and avalanches. Okay, rain. You have a lot of rain, water can get in and cause avalanches, landslides, etc. And then deforestation is a huge way we can get avalanches, right? One amazing benefit, in addition to many of forests, is that they have roots, right? And so these roots penetrate the ground, in the dirt, in the soil, in the rock, and these roots actually do a great job in holding that together, that material together. Right, so when you have a bunch of deforested area, right, those roots are no longer there. So they're a part of the forest that has been taken away, right? So these roots that were once holding the material together are now not there anymore. So any of that material that was once held by this root system is now gone. So the slopes are, as a result, much more unstable and can produce landslides. Okay, this diagram here shows the different types of landslides or avalanches that can occur. There's different types. You don't need to know them, but know that there are different types of landslides and avalanches that can happen. Okay, and you can refer to this diagram on that. Okay, tsunamis. So I got a question on that Science Daily assignment that we had way back about tsunamis and if they only occur in convergent boundaries. Well, absolutely not, but they are produced mostly by earthquakes, which are in convergent boundaries. So you can see in this diagram here, 72% of our tsunamis are caused by earthquakes, but some tsunamis are caused by landslides, volcanoes, atmosphere. So what is atmosphere? That's usually a meteorite impact, okay, or another unknown. So there's records of tsunamis out in the world in the rock record where we cannot attribute any known cause to. So they're still a mystery. Okay, but usually these tsunamis are caused by earthquakes. But we're going to look at some tsunamis that are caused not by earthquakes, which is cool in my opinion. Okay, so let's talk about fjords. So unfortunately, in this class, we don't have time to talk about all of the landforms that you'll get on Earth, but one of them is a fjord. And a fjord is a glacial U-shaped valley that has been carved by a retreating glacier. Okay, so glaciers are these destructive forces of nature that, as you know, carve and destroy things in its path. So as the glacier retreats and melts, it carves this U-shaped valley. And that U-shaped valley fills with seawater and forms a narrow, steep-sided inlet connected to the sea. So you can see these cruise ships that are in the fjord exploring this nice glacial valley. There's some nice glacial communities that are at the bases of these glacial systems. So you have these really steep, narrow inlets, right? With water, it's connected to the sea. Okay, so these are fjords. Okay, so what can happen in a fjord when you have a rockfall? Okay, so this is a GIF from one of my favorite geology movies called The Wave, and it's actually a Norwegian movie, and it's one of the best, most geologically accurate, as much as it can be, movies that I've seen, and it's on Netflix. So while you're binging Tiger King and you want to take a break, you can watch The Wave. There are English subtitles, so it's you can understand it, and this translates to "it has happened before" and "it has happened again." And it will happen again, excuse me. It's an excellent geology Netflix movie, so watch that in your own time. But this is a nice GIF showing you what happens to this poor community. So why is this happening? Well, what's really cool about this movie is that it is actually based on an event that happened in 1934. Okay, so this movie is based on this glacial community. So there's this small community at the base of a glacial valley. Okay, so they're nestled in this fjord, right? This narrow, really steep channeled glacial valley. Okay, so you can imagine this little community living at the base of this fjord, right? Well, this mountain here, which I won't attempt to pronounce, experienced a rock fall. So this slope was unstable. It dropped a bunch of rock into this fjord, creating this huge tsunami. So when a bunch of rock is deposited really rapidly into a body of water, right, where is the water going to go, right? It needs somewhere to go because now there's a bunch of material in the way of where this water used to be, right? So where's the water going to go? It's going to follow gravity and it's going to flow outwards. Well, what happens when you're in a really steep channel where the water can't go anywhere else but up, right? So it can't flow this way. It only has to rise. Okay, so in 1934, this Norwegian community experienced this really devastating tsunami because of this rock fall from this mountain right here in the distance, sloughed off a bunch of rock and deposited right in this fjord, right? This, where is it? The waves reached a height of 203 feet near the landslide, and 40 people were killed. This is one of the worst natural disasters in the history of Norway in the 20th century, and you can see some before and afters of this community, before the tsunami and after the tsunami, right? So there are tsunamis that can happen not just in the ocean, but in these different types of water bodies, this fjord as an example, right? So you can imagine this huge tsunami tidal wave coming for this poor village because of this rock fall, depositing all of this rock into the fjord at once, really rapidly, creating this huge tsunami. So pretty devastating. Another really interesting mega tsunami, which was recorded in Alaska because of an earthquake. A magnitude 7.8 earthquake on the Fairweather Fault in Alaska loosened 40 million cubic yards of rock into a narrow inlet. So here's the inlet in Alaska, and the fault is somewhere back here at the mouth of the inlet back here, and it dropped a bunch of rock into the bay. So here's a diagram showing that a landslide happened in this bay. It dropped a ton of rock into this little tiny narrow bay, producing a mega tsunami. And this mega tsunami was so tall. So we just talked about Taipei 101 a couple lectures ago, right, as being one of the tallest buildings in the world. This wave height in 1958 from this tsunami was higher than Taipei 101. So this is a huge, huge wave of water being created in this tiny little Alaskan bay. The record height of over 1,700 feet. What's even crazier about this story is that there were 3 boats in the bay at the time. So again, this is 1958, so this is recorded human history, so not too long ago. There were 3 boats in the bay. And from what I gather from this story, and you can read about it here in these links, it tells you about this mega tsunami in Alaska. 3 boats. There were 2 couples in each boat at the time of this mega tsunami. Unfortunately, tragically, one of those boats with a couple in it, they died because of this mega tsunami. They were basically carried by this huge wave and thrown out into the ocean and did not make it. Another couple in their own separate boat was also thrown out to sea, but they crashed into a log before they were in the open ocean, and they were able to escape the boat and lived, amazingly. It's known that the woman in that boat refused to get into the water ever since that day, which I cannot blame her. But the craziest story from this mega tsunami is that there was a father and son in a boat, the 3rd boat. And as the wave was rising, the father looks at this wave coming closer to the boat. He turns the boat around and decides to ride it like a surfer. This wave carries their boat, rips it from the anchor chain, and carries it above the tree line, and then drops them right back into the bay. And they amazingly both survived after riding this mega tsunami wave, which is absolutely insane to me. I hope you also find it equally as insane. So there's 4 people that survived this mega tsunami, which is pretty incredible. But it's one of the largest record height waves from a tsunami. And it wasn't even because of a subduction zone in the middle of the ocean, right? It was just because of a bunch of rock falling into this bay. Okay, so that's my little story on this mega tsunami. Okay, another geohazard that we can experience are sinkholes. Okay, so what are sinkholes? They are cavities in the ground that form when water erodes an underlying rock layer. So this usually happens with limestone, with marble, with dolomite. So if you all remember from our lab a few weeks ago now, dolomite and limestone and marble, they all have these different types of mineral, usually calcite, and these dissolve in acid. Okay, so limestone, marble has calcite in it, and these dissolve in acid. Well, rainwater and surface water can be slightly acidic. Okay, and so when this water that's slightly acidic gets into the rock and it percolates down from the soil and gets into the rock, that rock will dissolve over time, right? Because you're dissolving the rock with the rain and the surface water, right? You create these little cavities in the rock that are underlying roads, structures, building, etc. And then over time, that rock is eventually going to collapse. When that rock collapses, all of that material on top is also going to collapse with it, and it's going to collapse into this sinkhole. So you can see these pretty scary sinkholes that have formed in the ground. That is how they form. You can watch this video on different types of sinkholes. They're terrifying, but they do happen all the time. Okay, and so sinkholes create this unique type of topography called karst. Okay, and again, this is caused by chemical weathering dissolution. So you have this acidic rain and acidic surface water dissolving the rock. Okay, and this creates all of our really cool caves and caverns that we have in the world, most of them. Okay, you have some of the biggest cave networks in the world are in our country, in Kentucky, and this is all karst topography. Okay, and so this can occur in limestone. It can also occur in gypsum and other types of evaporitic rocks like salt, any type of material where you can dissolve it through water. You can create these sinkholes. So sometimes you can have that in sandstone too. It's not as common. Usually it's in limestone, gypsum, marble, etc. Things you can dissolve. Okay, so these are how our cave systems and our cave networks are formed, okay, based on this water that percolates into the ground and dissolves it, creating these nice caverns and caves and sometimes sinkholes. So you can see in this karst topography diagram, you have some sinkholes created on the surface, and then you have your network of caves underground. Okay. These sinkholes can also be in the middle of the ocean. Okay, so these sinkholes can flood. Here's an unflooded sinkhole where you have some type of cave roof, but there are sinkholes that happen in the ocean. So usually these happen in really shallow seas. So you're not going to typically find a sinkhole at the bottom of the ocean, but where you have a coral reef, really shallow seas with a limestone type of crust. So I'm pretty sure this sinkhole is in Belize, in Central America, but you can have this in all parts of the world where you have these shallow seas with limestone, right? That limestone collapses, creating this sinkhole in the middle of the water. Okay, so those are sinkholes. Where do they happen in America? So there's some nice karst topography map. So you can see basically all of Florida is carbonate rock, right? So this is where you're going to have most of our karst topography located, right? So Florida, if you ever wondered why does Florida have so many sinkholes? Why is Florida always collapsing? Well, it's because of the limestone, and it's because of the carbonate rock that comprises Florida, right? The water is going to get into the rock. It's eventually going to dissolve it, and it's going to break down, creating sinkholes and karst. Okay, you also have some karst topography in the middle of the country, a little bit East Atlantic in Kentucky. This is where we have some of our greatest, most beautiful, magnificent caves. Kentucky, world's longest cave, created by this karst topography. You can see sinkholes in different topographic maps. So you can see, if you zoom in on this map here, you have little depressions in our maps, right? This is how you can locate sinkholes in karst on topographic maps. If you were to look at one, they're basically little circles with dashes pointing in towards the circle. Okay, so that's indicative of a bunch of different sinkholes and depressions. Okay, so sinkholes are pretty crazy, and this is how they form, and this is where they're located. Okay, so again, watch these videos. These are really cool videos on these processes. Okay, and one of our last ones, I think we have two more, is radon. So radon is a naturally occurring radioactive gas, right? So we all know about our radioactive elements. So uranium is one of our really most common ones, right? Uranium and lead. These radioactive elements are what allows us to date rocks, right? The decay products of these rocks allow us to date them. Well, the same type of radioactive decay gives us radon, and this is when we have our bedrock. So here's a nice picture diagram of that. This is when our bedrock, if it has large amounts of uranium in it, over time, that rock will produce radon as it decays. Okay, that radon usually gets into our basements, right? Because our bedrock is usually located within our basements. Okay, and you can monitor, so you can test your radon levels in your basement, and you can see if your home is impacted by radon levels. So here's a radon map of Massachusetts, and you can see Massachusetts actually has very high amounts of radon. in it because the rock in Massachusetts just has high amounts of uranium in it. Other parts of the country might not have as much uranium in it. So if you have a home in Massachusetts and you're in one of these counties with high levels or moderate, you may want to make sure that you have a radon test in your basement, monitoring the radon amounts that are in your home, because these can cause really harmful effects such as lung cancer if you're exposed to radon for long periods of time. Okay, and the last one is floods, and I don't want to get too into this because I am going to go over this more when we talk about climate change in the next couple weeks. But floods happen without tectonic activity, obviously. So these happen for many different reasons. 75% of all presidential disasters are associated with flooding, which I thought was interesting. And these can be caused from levee failures. These can be man-made or natural, like natural dams of rock and ice. When these collapse that have been holding back water, this can cause flooding. And it also happens when when we have severe rain events and the substrate, so the material like the soil or on the surface, they're not able to absorb the water as fast as the rivers can carry it away. So when that happens, we have large flooding events. These do not have to happen in coastal areas. So when we think of floods, we usually think of places on the coast. These do not have to happen on the coast, right? So we can have flash floods in the middle of the desert, like so. These happen usually during monsoon seasons when you have large, quick rain events happening and the soil does not have the absorption quality as other soils. So clay soil does not absorb very easily. So when rain events happen in the desert, usually you have these flash floods because the water is not able to absorb it as well. You'll also have floods in the middle of the mountains. So I have some flooding videos of Vermont. So if you remember several years ago, we had some pretty significant hurricanes. Irene hit the Northeast and parts of Vermont, New Hampshire were inundated by floods because the rivers could not accommodate all of the rain. So I have a couple of videos of flooding that can happen places that are not even close to the coast. Okay, so floods can happen really anywhere. And then we have sinking cities. So these cities are usually on the coast, and whether it be due to climate change or subsidence, these cities are sinking and are eventually will be underwater. So we all know Miami, New York City, Venice, are all examples of sinking cities. These cities can also sink because of the substrate. So a lot of times these cities are built because of their accessibility to water in ports and harbors. So these cities are usually built on lagoons or places of unconsolidated sediment, so like clay, basically. And over time, because of the weight of the buildings, because of the population density, these layers will compact and compact and compact and compact over time. And so not only do they experience flooding because of climate change and sea level rise, but they're experiencing flooding because their cities are literally sinking into the ground because they're just being compressed to great quantities over time because of the material that they're in. Okay, and so that's the end of the slide. I'm not going to go again into sea level rise because I want to save that for a couple weeks, but that's all I got. So I'm going to stop here. And that is the end of our lectures for this week. So I will see you all next week.